Hey guys, I just got a short lecture for you here to go over some things that we're going to be doing this week. And I've had to re-record this a couple times because I found some discrepancies in how they have the labs laid out in the modules. And actually, there was a lot of repeats in it. So let's look at the calendar first so you'll see what I mean. Uh, Originally, I had it set up, and if you looked at the calendar earlier, you might have saw this earlier today, or I think I did some of it yesterday. I had lab 5 and 6 and 7 here. Well, come to find out, 7 is just 5. 7 has 5 and 7 in it. And 6 was just a repeat of what we did from last week. I think it was the lab 4. So I thought, well, why do lab 4 over? So it was all screwed up. Anyway, right now, when you look at the assignments, lab 7 is the only one that we have there that we're going to start working on this week. I have it due on the 17th. But we may not get it all done. There's quite a bit in there, but I think we can. I've got some other things to cover with you in class as well, and so we'll see. But so we got that gap open, and then I'll update our schedule accordingly after I see how everybody does. But I just have one there for Thursday because I can't add two different due dates for the same assignment. So you have right there. I could create another assignment, but I'm not going to. It just clutters up everything. So it's the same assignment for both groups. So the Tuesday group will work on it, and then the Thursday group. And if we get done, we'll do something else next week. If not, we'll continue it next week because there's quite a bit in there, and there's a lot of stuff I got to cover with you. So we'll just see how it goes. So, and then I also have added a lesson here, and I'll probably give you copies of that, of this, and let you work on it in class too, as well. And if you don't get it done in class, you can do it at home. You don't have to submit any of this online. You just bring your papers to class, and I'll grade them for you like that. It's just easier to have them there, and then I don't have to mess around with digging them out of the computer and whatever. So anyway, this coming week, Lab 7 and Learning Activities here, Mo5 is what it's called. I'll show you a little bit about each one. So we go back to our course here, and I've got it in student view, so it looks like what you're going to see. So we go to the modules here and go down here. So 5, again, do your e-learning there, your e-learning activities in 5 and 6. The e-learning activities are still good. It's just the labs will all be covered in 7. So circuit analysis lab number part 3 is what we're working on. And I'll just show you briefly what you're going to have to learn. The big learning here, I think you already know how to do most of it with, like series resistors. What's the formula for series resistors? Well, it's R1 plus R2 plus R3, which they show you right here. And it's funny, they ask you to record these answers. They ask you to do these calculations, but then they give you the calculation and the answer. So it's kind of busy work, but I guess it helps sink in. Then of course, you got to hook the resistors up and measure them. So, yeah, and then, but what I really want to talk to you about, because I think we're pretty good with all this. We know how to do it. If I can find it here real quick, we're going to look at measuring, I think it's under skill 4, calculate, okay, no, that's calculate mainline current, which I think you can do pretty well, and I think it's number 5. calculate the total parallel resistance, okay? So if you look at this wonk, there's a couple different formulas here, and I'll show you a couple others, the other two in class. But for now, this formula, RT equals 1 over R1 plus 1 over R2 plus 1 over R3. Okay, so when people see that, they like freak out and panic and whatever, but don't do it because it's not that bad, and I'm going to show you how to do it very easily. So I'm going to reduce my screen down here a little bit, and you have a calculator on, if you have Windows. I don't know about Apple. I don't use them, so if that's what you have, I'm sure you probably have a calculator on there. And I would also recommend that you get a calculator like this, the scientific calculator. They're real cheap, maybe $5 or $10, I don't know. I'll bring a couple extras to class. We may have some available there at the school for you. You can use your phone, but you can't use your phone on a test, so we'll have to provide calculators for you when you take the test. Now, if you we're going to be taking the midterm there in the computer lab, so you may be able to use the calculator on there. We'll see. We'll work that out later, but I wanted to show you what to do here. I'm going to see if I can shrink this down a little bit. Yeah. So that what you're calculating there is the reciprocal of the resistance. You're actually calculating conductance of the circuit, how much current can that circuit carry. So every time, like I told you before, every time we add a branch to a parallel circuit, we reduce the total resistance and we increase the current carrying capability of the circuit. We can add more current to the circuit that way. So how do we calculate that? We have 150 ohms. Let me slide this over where you can see it. We have 150 ohms, 300 ohms, and 100 ohms. So I'll walk through the keystrokes with you here. So 150, 150, and then you notice right here we have a little handy dandy key, 1 over X. That's your reciprocal key. So I entered 150. Now I hit the reciprocal key, and now I'm going to add it plus 300 reciprocal, and our next value is 100 plus 100 reciprocal equals, and now here's where a lot of people make mistakes. They write down that value for the resistance, but they forget that all of these here, because what I did was everything that's under 1 here. So 1 over R1 plus 1 over R2 plus 1 over R3. So we still have to deal with this 1 here. So that means I have to hit my reciprocal key 1 more time. And bingo. So the total resistance, total parallel resistance, or they say equivalent resistance of this parallel circuit is 50 ohms. Now there's a couple things that you need to know about this, that the total resistance in a parallel branch will always be less than the smallest resistor in the branch. So if you come out with a number that's bigger, then you've done something wrong. You've calculated wrong. So go back and look. So it's always going to be smaller than the biggest or the smallest resistor in the branch. So the power supply only sees, with all 3 of those resistors hooked up, the power supply only sees 50 ohms. And we'll talk more about that later, but look at that. So you can see that they had the same values as I did there, and they came out with 50 ohms, but I showed you the keystrokes on how to do it. And I'll go over this again with you in class. So that's one thing I wanted to show you, and something that we're going to be working on here in class. And that's why we'll probably take next week to work in number 7 too, or at least stuff that's covered in lab number 7. So let's go back here. Let me see if I hit the back key, if I can get back a little. Yeah. So now let's go that back up to 5 here, because that's there. And where'd it go? Yeah. This thing right here, the Mo5 Learning Activities. And I'm going to, like I said, I probably will print these out for you. Is it going to let me open it? There we go. So you got series circuit calculations, and so they give you some problems here where you have to calculate the different values in the circuit using Ohm's law. And there's another one. These are all series circuits, I think. And then they ask you some questions here. So I think I'll probably give you some time in class to do this. I'll print these out for you. So that's that one, just more problems to work with. And it's going to let me go. Okay, there we go. And then so this one I thought was pretty good. Solving the series circuit. Is that the same one? No. No, that's just more of the same kind of problems. So give you some practice and get you ready to take some tests here with this. So again, we will have those two in class for you this week to work on as well. So we got that to do in the lab, and I think we'll be in pretty good shape. If you've got any questions, make sure you shoot me an email. If you're having any problems figuring something out that you're working on at home, don't beat your head against the wall. Send me an email, and I'll get back with you just as quick as I can. I'm usually around unless I'm out at the shop working, but I can still get here, within 3 or 4 hours after your email. So I'll see you all in class this week. Everybody have a good rest of the day here. I guess it's Sunday evening for me, Sunday afternoon, and have a good Monday. I'll see you all Tuesday and the rest of you on Thursday. Take care, everybody.